Today, we're going to tackle one of the biggest questions imaginable. What if the Big Bang wasn't really the beginning? What if the universe never began at all? Okay, let's just dive right into it. This is a huge idea, one that really challenges a core assumption most of us have about the cosmos. We're all taught that the universe exploded into being, right? But what if that whole picture is based on a fundamental misunderstanding of physics and of time itself? You know, the picture most of us have in our heads is pretty simple. There was this single, super dense point that had everything inside it, and then boom, it exploded, creating all of space, all of time, all the matter we see. It's a nice, clean, simple origin story. But here's the really unsettling part. The moment we try to look at that supposed first instant, our entire understanding of the universe just breaks. The laws of physics that we count on, general relativity, quantum mechanics, they spit out nonsense. Infinities. It's not just that we don't know what happened, it's that science itself, as we know it, just stops working. And that leads us to this really fascinating possibility. What if the roadblock isn't a failure of our equations, but a failure in our basic assumption? What if we're desperately trying to find a beginning for something that never actually began? So here's how we're going to break this down. First, we'll look at why the idea of a beginning is so tricky for physicists. Then we're going to explore a totally different way of thinking, time as a cycle. We'll put these two ideas side by side and see what it all tells us about one of the biggest unanswered questions out there. Let's get into it. Okay, so what does the Big Bang model actually tell us? And maybe more importantly, where does it just go silent? Right, let's clear up a huge misconception right off the bat. The Big Bang theory is not a theory of creation. It's a theory that describes the universe expanding from an incredibly hot, dense state about 13.8 billion years ago. It explains the bang, sure, but it doesn't tell us what lit the fuse. That first instant with what physicists call a singularity. But here's the thing you have to understand about a singularity. It isn't a physical thing. It's a mathematical boundary. It's the point where our equations just break down. Think of it like a signpost on the frontier of knowledge that says, beyond this point, our current map of physics is useless. So this wall in our understanding has really forced physicists to get creative. I mean, if the singularity isn't the true beginning, then what was there? The question itself might not even make sense if time as we know it started there, but that hasn't stopped some of the most brilliant minds from proposing some wild alternatives. And this has led to some truly mind-bending ideas. You have inflation theory, which suggests a crazy fast expansion just after the Big Bang. You've got cyclic models, which imagine our universe in a constant loop of expanding and contracting. Eternal models say the universe in some form has just always been here. And of course, the multiverse idea, that our universe is just one of countless others bubbling into existence. So the crucial point to get here is that this isn't science giving up or avoiding the question. It's science pushing right up to the very edge of what its current language, which is mathematics, can actually describe. The problem of a beginning is truly one of the greatest frontiers left for us to explore. So if physics hits a wall, where do we go from there? Well, sometimes to move forward, you have to take a step back and just look at the problem through a completely different lens. Let's explore a more philosophical take on the nature of time itself. And this really is the key philosophical question, isn't it? Is our deep-seated need to find a first cause, a day one, is that actually a requirement of reality? Or is it maybe just a habit of our own linear way of thinking?
Now, let's be crystal clear. What we're talking about here is not a competing scientific theory. It's a different knowledge strategy, a different way of reasoning about time, drawn from Sanātana traditions, the ancient systems of thought that formed the basis of Hinduism. In this framework, time isn't a line with a start and a finish. It's a vast, repeating cycle of creation, existence, and dissolution.
And this comparison really gets to the heart of it. The linear view is always searching for that one single event-based origin, that one moment of creation. The cyclic view, on the other hand, sees all of existence as a continuous process. The universe emerges, dissolves, and then reemerges in a completely endless loop. So you see, in this kind of framework, asking what happened before the beginning becomes a meaningless question. Why? Because there is no beginning. There's only this unbroken, repeating chain of cause and effect. The whole problem of needing to find a first cause just dissolves. All right, so let's put these two ways of thinking, the linear model from physics and the cyclic model from philosophy, right next to each other. Now, the goal here isn't to say one is right and the other is wrong, but to see what we can learn just by comparing their structures. This table really lays out the two different approaches. With the linear model of physics, you treat time as a coordinate, with a starting point, and that forces you to deal with the problem of the singularity. But in the cyclic model, time is seen as a continuous flow, and that problem of a beginning gets reframed as just part of an ongoing process. It's a really fascinating comparison of intellectual architecture.
And this, right here, is the central insight. The way we frame the question totally determines the kinds of answers we can find. If you define time as a straight line that has to start somewhere, you are forced to confront the problem of what came before. But if you define it as a circle, that specific problem just vanishes and is replaced by others.
So what's the big takeaway here? Why does exploring these different ways of thinking about the universe even matter?
Well, it's really all about perspective. It teaches us that, maybe our current scientific tools just aren't up to the task of answering the ultimate question of origins, yet. It shows us that how we build our questions is every bit as important as the answers we get. And maybe most importantly, it shows that we can have different profound systems of thought exploring the exact same mystery without needing to be at war with each other. It really calls for a bit of humility. And so we're left standing before this profound mystery. On one hand, science is pushing at its absolute boundaries, coming up with these fantastic new ideas. And on the other, philosophy is there to remind us that maybe the boundaries themselves are of our own making.
Ultimately, this whole struggle to understand where we come from, it reveals just as much about us, about the nature of our minds and how we know things, as it does about the cosmos itself. The question of the beginning, it remains the most fascinating puzzle of all.